So annuity immediate is a lump sum amount paid at the end of each interval of time. For example, at the end of every month or at the end of every year. Present value is a lump sum amount where amount is obtained first and installment is paid later, whereas future value of an annuity is nothing but the equal installments are paid first and the lump sum amount is obtained later. You should start an investment of 34,287.05 with equal installments for 30 years so that his wife will get rupees 40 lakhs after his death. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session we are going to take up the new chapter, Annuities. So in this session we are going to study the weightage of marks distribution from this chapter. From the chapter Annuities, you will be having one multiple choice question and one question for 5 marks. Overall, 2 questions, in total 6 marks. And in this session, we are going to study about the future value and present value of an annuity immediate. Before that, let us see what do you mean by annuity. So annuity is a fixed sum paid at regular intervals of time under a certain condition. These equal intervals may be either a year or half a year or quarter year or month, etc. For example, repayment, installments of loan, LIC premiums, deposits in a recurring account. So anything or any lump sum amount which you will pay in equal installment for a certain period of time under certain condition is nothing but annuity. So here in annuity, we have mainly 2 types. One is annuity immediate and the other is annuity due. So what is this annuity immediate? So annuity immediate is a lump sum amount paid at the end of each interval of time. For example, at the end of every month or at the end of every year. So if the payments are made at the end of each interval of time, the annuity is called as annuity immediate. And if the payments are made at the beginning of each interval of time, the annuity is called as annuity due. Now, other terms related to annuities are present value of annuity. So, what is this present value of annuity? So, it is the sum of the present values of all the installment. That means, in other words, we can say it is the lump sum amount obtained before and paid later in equal installment. So that means, for example, you will pay 1,000 rupees of an EMI every year. So for example, you will purchase a phone of cost 30,000 and you will pay that later in every month in the form of an EMI in equal installment in like 3,000 per month, etc. So this is nothing but present value of an annuity. Now, future value of annuity. So it is the sum of the future values of all the installment. That means, in other words, so you will be obtain the lump sum amount later, but you will pay the equal installment previously. So here in the lump sum amount, it is obtained at the end and the annuity is paid before, then the lump sum amount is called as the future value. So for example, your LIC policy, you will be paid in equal installment once in a month or thrice in a month. Like in a year, you may pay 2 times. So like that, after that certain number of period of years, you will get a lump sum amount which is called as the future value. So present value is a lump sum amount where amount is obtained first and installment is paid later, whereas future value of an annuity is nothing but the equal installments are paid first and the lump sum amount is obtained later. So today in this session, we will learn to calculate future value of an annuity immediate as well as present value of an annuity immediate. So we have a formula to calculate the future value of annuity immediate. So I told you annuity immediate is nothing but the payments which are made at the end of each interval of time. So here we will calculating future value of annuity immediate as well as present value of annuity immediate. Now, the future value of annuity immediate is given by F is equal to A into 1 plus I whole power n minus 1 divided by I. So, here F is the future value, A is nothing but the equal installment or also called as annuity, and I is nothing but rate of interest in decimal, and N is the number of installment. So, when I say number of installment, it may be in months also, it may be in a year also, like that. N is calculated as number of installment, not as number of years. Now let us take the problems. A company needs 1,50,000 at the end of 10 years from now. It would like to set aside an equal amount each year from its profit. If the present market rate is 15%, how much should be the annual amount to be invested? So the question is, a company needs 1,50,000 means which needs a future value. It is given as 1,50,000 and the number of years is, that is 10 years. At the end of 10 years, after 10 years, the rate of interest is given as 15%. So we need to calculate the value of an annuity, that is A. So using future value, we have the formula A into 1 plus I whole power n minus 1 whole divided by I. Now I have F here, I need A. So A is equal to F into I whole divided by 1 plus I whole power n minus 1. Now F is 1,50,000. I is 0.15 whole divided by 1 plus 0.15 whole to the power 10 minus 1. So you need to calculate 1.15 whole to the power 10 minus 1. So the numerator value will be equal to 22,500 and the denominator value, that is 1.15 to the power 10 minus 1 is equal to 3.045. Now dividing 22,500 by 3.045, we'll get the value as 7389.16. So this is the value of an annuity. So that means an amount of rupees 7,389.16 rupees should be paid as equal installment to get a future value of 1,50,000 after 10 years. Next question, find the future value of an annuity of 5,000 at 12% per annum for 6 years. So we know the formula, F is equal to A. A is 5,000 into 1 plus I. I is 0.12 whole to the power n, 6 minus 1 whole divided by I, that is 0.12. So here it is 5,000, 1.12 whole power 6 minus 1 divided by 0.12. So it's a direct problem. We are calculating the future value here. So evaluating the numerator, we will get the value 4869.11 divided by 0.12. So dividing this, we'll get F is equal to 40,575.9 in rupees. So this is the future value for the given annuity for 6 years at 12% rate of interest. Next question. In how many years an annuity of rupees 100 amounts to 3,137.12 and 4.5% per annum compound interest? So here we need to calculate the number of years, that is n. So we know the future value F is equal to A into 1 plus I whole to the power n minus 1 divided by I. Now cross multiply this, we will get Fi by A is equal to 1 plus I whole to the power n minus 1. Now shift minus 1 this side, we will get Fi by A plus 1. So this is equal to 1 plus I whole to the power n. Now since we need to calculate n here, so here, now let us substitute the values here. We will get 1 plus interest rate is 4.5. In decimal it is 0.045 whole to the power n. So the future value is also given, that is 3,137.12 into 0.045 whole divided by annuity is 100 plus 1. So here we will get 1.045 whole to the power n. So solving the right hand side here, we will get the value of 0.4117. Now here I need n which is in the index form. So whenever any value is in the index form, we'll apply log to make it as a whole number. So if we apply log on both sides, I'll get n log of 1.045 is equal to log 0.4117. So using logarithmic table, we can find the values of these two. So we have this in the form of log 0.4117 divided by log 1.05. So this is equal to 0.3823 whole divided by 0.0191. So dividing this, we'll get n is equal to approximately 20 years. Next question. Romeo, aged 40, wishes his wife Juliet to have 40 lakhs at his death. If the expectation of his life is another 30 years and he starts making equal annual investment at 8% per annum compound interest computed semi-annually, how much should Romeo invest every year in an annuity? So here he wishes to his wife that she should get a 40 lakhs. That means the future value is already decided. That is, F is equal to 40 lakhs. Now, so his period of lifespan expectation is 30 years and the rate of interest is 8% per annum here. So it is 0.08, but this is compounded semi-annually here. It is semi-annually. So therefore, first we need to find out the effective rate of interest for year. Now we need to calculate what is the investment he should make so that after 30 years, she'll get 40 lakhs. Now before that, let us calculate the effective rate of interest. So which is equal to 1 plus I divided by Q whole to the power Q minus 1. So here Q is number of installments in a year. So they have clearly told that 8% compound interest computed semi-annually. That means in a year, so Q is equal to 2 and rate of interest is 0.08. So therefore 1 plus 0.08 divided by 2 whole to the power 2 minus 1. So evaluating this, we'll get the value of 0.0816, or we can also write this in percentage as 8.16%. Now we need to calculate the value of an annuity. So we know the formula F is equal to A into 1 plus I whole to the power n minus 1 whole divided by I. But here I is replaced by R now. So therefore, we need A here. So wherever I have I, I'll just replace with R. So F into R divided by 1 plus R whole to the power n minus 1. So now substituting the values here, A is equal to future value is 40 lakhs into R value is 0.0816 whole divided by 1 plus 0.0816 whole to the power 30 minus 1. Now the numerator value is 3,26,400. So you need to take 1.0816 to the power 30. You need to multiply 30 times the value and then subtract by minus 1 using your calculator. Then the denominator value is 9.5146. If we divide this, we'll get value of A as 34,287.05 in terms of rupees. So that means he should start an investment of 34,287.05 with equal installments for 30 years so that his wife will get rupees 40 lakhs after his death. Next question. Find the future value of an annuity of 200 payable every month at 12% per annum compound interest computed every month for the next 2 years. So here the value of A is given, so that is rupees 200. Interest rate is given, so that is 0.12, but it is computed every month for the next 2 years. So that means first we need to calculate the effective rate of interest. Or I can also take I 0.12 divided by 12, so per year, so 0.01. Now n is equal to the number of installment. So for 2 years every month means the number of installment is 24. So now we have calculated I for 1 year. So therefore the future value is A into 1 plus I whole to the power n minus 1 divided by I. So here A is 200. So 1 plus 0.01 is 1.01 whole to the power 24 minus 1 whole divided by 0.01. So evaluating this, we'll get the value of 5394.69 in terms of rupees. So this is the future value of an annuity, 200 at 12% payable every month for the next 2 years. Next is we are finding the present value of an annuity immediate. So here it is given by the formula P is equal to A into 1 plus I whole power n minus 1 divided by I into 1 plus I whole power n. So it's the same as the future value. The only thing is the difference is you have 1 plus I whole power n in the denominator. So P is the present value, A is annuity or the equal installment, I is the rate of interest in decimal, n is the number of installment. Now let us take a problem related to the present value. A man borrows 20,000 and agrees to pay the borrowed amount in 10 equal installment at the rate of 6% per annum. Find the amount of each installment. So here we need to find A here. So a man borrows 20,000 means the present value is 20,000. The rate of interest I is 0.06 and the number of installment is equal to 10. So n is equal to 10. So we have a formula P is equal to A into 1 plus I whole power n minus 1 whole divided by I into 1 plus I whole power n. So we need the value of A. So A is equal to P into I into 1 plus I whole to the power n whole divided by 1 plus I whole to the power n minus 1. Now substitute the value. Present value is 20,000 here into 0.06 into 1 plus 0.06 is 1.06 whole to the power 10 whole divided by 1.06 whole to the power 10 minus 1. So now solving the numerator, the value is 2419 whole divided by 0.7908. So if we divide these two numbers, the value is 2717.46 in terms of rupees. So this is the annuity or the equal installment to be paid for 20,000. Next, Raj wants to invest a lump sum amount in the bank so that he can get an annual income of 15,000 every year for the next 10 years. If the bank offers 16% per annum compound interest, what is the amount he should invest today? So here he'll get an equal installment of 15,000 every year for next 10 years. That is for n is equal to 10 years. So and the rate of interest is given by bank is 0.16, that is 16%. We need to calculate the present value that he should invest so that he'll get 15,000 every year for the next 10 years. So therefore this is equal to, using the formula A into 1 plus I. So that is 1 plus 0.16 whole to the power 10 minus 1 whole divided by I 0.16 into 1 plus I whole power n, that is 16 whole to the power 10. So solving the numerator and denominator, we will get an amount of rupees 72,498.412. So this is the present value he should invest in a bank so that he'll get 15,000 every year for the next 10 years. Next question, Sanjana sold to Rima a machine. The cash price of which is 10,000 payment will be made in 3 equal installments, annual installments at 10% per annum interest compounded quarterly. Each installment is payable at the end of each year. Calculate the amount of annual installment. So here she has sold a machine which cost for 10,000 and that 10,000 will be made equally in 3 installments annually. But here the compound interest is calculated quarterly. So quarterly means 4 times in a year. So therefore first we need to calculate the effective rate of interest, and if each installment is payable at the end of each year, we also need to calculate the annual installment. That is, we need to calculate the annuity here. So first we will calculate the effective rate of interest R, which is given by 1 plus I by Q whole to the power Q minus 1. So because the rate of interest is 10%, here it is 1 plus 0.1 and compounded quarterly means number of installments in a year is 4 minus 1. So solving this, we'll get R is equal to 0.1038. So that is 10.38%. Now we need to calculate annuity value using the present value formula. So that is equal to P is equal to A into 1 plus I whole power n minus 1 divided by I into 1 plus I whole power n. Cross multiplying this, we'll get P into I into 1 plus I whole power n whole divided by 1 plus I whole power n minus 1. So this is equal to A. Now here the interest is replaced by R value. So therefore the present value is 10,000. And here we have I whose value is 0.1038. Next we have 1 plus I whole power n. So here n is equal to 3 equal annual installment. That means 3 years. So therefore here it is 1.1038 whole to the power 3 whole divided by 1.1038 whole to the power 3 minus 1. So this is equal to, after multiplying the numerator, we'll get the value as 1395 whole divided by 0.3448 in the denominator. Now dividing these two numbers, so we'll get an amount of rupees 4045.82. Next question. Find the present value of an annuity of 500 payable for 10 years. Hence, when interest of 10% is compounded half yearly. So here the compound interest is calculated half yearly. So we need to calculate the effective rate of interest. So first let us calculate R. R is equal to 1 plus 0.1 divided by 2 because it is half yearly minus 1. So this is equal to 0.1025. Now present value is A is 500 into 1 plus I whole power n, that is 1 plus 0.1025 whole to the power 10 years minus 1 whole divided by 0.1025 into 1 plus 0.1025 whole to the power 10. So this is equal to 826.64 in the numerator, 0.2719 in the denominator. So evaluating this, the present value is equal to 3040.23 in terms of rupees. So thus in today's session, we have discussed about the future value as well as present value of an annuity immediate. So I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.